This is Dr. Obulakonda Reddy, Department of CSC, Cybersecurity. Now today the topic we'll discuss now, Introduction to Grid and its evaluations. So grid computing is a computing of different resources, to have a different collection of resources to achieve a common goal. But this definition has to be told at different ways. What is the grid here now? So many definitions exist in the literature. We'll see in a different authors has to be presented with a different ways. But the most definitions, early definitions, we have to consider that Foster and Kessel in the year 1998. He told about that. What is the grid? Grid is a it is a computational grid that is a combination of hardware and software infrastructures that provides dependable, consistent, pervasive, and inexpensive access to high-end computational tools. So this is the definitions has to be proposed with a poster. And we'll see in another definition in the year 1969. Kleinrock is a scientist has to be proposed with a Kleinrock in the year 1969. What is the grid? Yeah, it is a spread of computer utilities which, like present electronic and telephone utilities, will service individual homes and offices across the country. So it is individually provided with the offices that is a combined into one grid. Homes, that is also a combined. What is the computer utilities will utilize with the homes, that is also one grid. Offices utilizes with the computer utilities, that is also one grid. And we have to categorize like that. So this definition has to be proposed with a Kleinrock in the year 1960. So grid is nothing but it is a computing resource. It has computing different resources to achieve a common goal. Now grid computing, how it has to be coordinated with a different goals. Here VIVO, virtual organizations. This is called VIVO. VIVO is named called Virtual Organization A, Virtual Organization B. It has a group of softwares as well as the resources that has to be a sharing here. So now grid computing, coordinated resource sharing. This is another definition you can propose with poster. Like coordinated resource sharing, that is the main thing is resource sharing. So now coordinated resource sharing and the problem solving, that has to be solve a problem in dynamic multi-institutional virtual organizations. Virtual organization, simply short form write as a VIVO. VIVO A. A means it is one of the virtual organizations, and VIVO B means it is another virtual organization. Now in this one, it has observed that it is a disparate here now, disparate users. Here take as partition network, and here R is a programming language that has to be statistical view. We can see with a statistical view whatever we have a use of that, then that can show in a use of our language that can statistical view we can see. So this is the diagram has to be approached with a virtual grid computing. Like this is a one grid. This is overall with a computed one grid, and this is also taken as another virtual organization grid. Both are interchanged without a interaction with a server. Decentralized works. So without interaction with servers, the data as well as the resource sharing. Main thing in a grid computing, the resource sharing as well as the data has to be a changes. Sharing the data as well as the resource savings like printer, softwares, hardwares. We can sharing with the different resources. So this is the we here concerned with here now. So different the virtual organization C, virtual organization B. It has to be interconnected and that has to be sharing with the data as well as the resource sharing. That is the main thing we have observed here. So this is proposed with the poster. He is the scientist, has to be proposed with this another definition: grid computing, resource sharing, and problem solving in dynamic. So here our language, a set of people has to be sent with some data that has to be used our language. That statistical view we can see. what is the how many there we can statistical view we can see it. In the continuation of grid computing, what are the here information grid? One thing is the information grid that have large access to distributed data like web access. We have a large amount of data has to be sharing in internet. Through a web, we can large access to distributed data. Like you can see with large data has to be transferred. So this type of grid comes under information grid. And second thing is a data grid that have the management and the processing of very large distributed data sets. So these types comes under data grid. A data only purely on data management and processing of very large distributed data sets. Computing grid is nothing but it is the another type that has to be a meta computer. So take a one keyword. Again, it has to be such a another keyword meta words, meta computer. It is taking a one word distributed grid computing. Take a grid. Again, take a one word metadata. Data about a data that is called as a metadata. So now the type of computing is called as computing. So now we will see here three types: information grid, data grid, and computing. Now, majorly we have observed the differences between what is the differences between parallelism versus grids. So some again we have to recall some points to here. Grid it has to be see at 1996. The parallelism is the old one. Compared to grid, the parallelism is the older. The classification has to be done with it has to be done in 1972. But the grid concept has to come under 1996. So the parallelism is the old. Parallelism is nothing but parallelly it has to be done the n number of tasks at a time. Grid is nothing but it has to be data, resources has to be same in a different computers, all over geographical locations, different locations, but the theme is the same. The final achieved goal is the same. We have to use resources and sharing data, sharing resources and data. So that is comes under grid. Parallelism, take a one problem that has to be executed with a different missions. So less amount of time that has to be less amount of time. Our task has to be executed in a parallel. So that is the difference now. So motivations. Why we are go for here? Need more computing power, like weather forecast, atomic simulations. We want to use more computing power. Then other thing is need more storage capacity. Like nowadays we use gigabytes, GBs. Now go for it, petabytes and more. More than that, peta is more than GBs. GBs. It is called PBs. Now, in the other term, improve performance. So now consider the improve performance. We observed in three ways. What are those here? Work harder. If you want to work should be harder, then use faster hardware. If I want to go for the work harder, then use a fast hardware. If work smarter, then use optimized algorithms. The work should be done in a less amount of time as to execute. The algorithm should be optimized. And it has to be used for getting use more compute. Now this is the three ways we can achieve the performance. Taking help from other computer, then get help. Taking from help from different computer, the problem has to be solved with less seconds. Less seconds has to be executed our task. The performance. How to measure the performance in mathematical speed up of a computer. So now here ideally it is grows linear. Now see here speed up. TS. What is the TS here? The best time to process a problem. It has to take for sequentially. TS is the best time to process a problem. Best time to process. Now here then the parallel processing. Taking a parallel processing, parallel TP. Time to parallel processing time equal to TS. The best time to process by number of processes. TS by P. TP equal to parallel processing time. If I want to compute it with a parallel processing, TP equal to TS, best time to process. Best time to time taken by a processor by total number of processes. TS by TP. The speed of, if I want to find out with the speed of a computer with a parallel processing, TS by TP. This is a formula, speed up. Now, whenever in a saturated region, the more resources are available, we want to improve a performance, we have apply for Amdahl's law. So more resources are existed here now, but the performance is in constant. That time you have to apply for Amdahl's law. So the parallel programming is purely sequential and a parallelized path. TS equal to F plus T. The improve TS equal to TS is the best time to process equal to fast time to complete it. Enhancement for processing is required or not to required for a enhancement. You have to take in for these two and computed with a Amdahl's law. Now speed of limited is equal to S equal to F plus T by F plus T by P. But all should be a less than two processors. And scale up. We want to add up a more thing. Then we use TPS. So here TPS is the time to solve a problem of size S with the P process. Time to solve a problem, that is called TPS. Time to solve a problem. Here S is a size, P is a process. Time to solve a problem. Now TPS should be a time to process a problem of size N into S and N into P process. Certain N here N into S with N into P process. So this is the performance evaluation at a speed up as well as the scale up. Now here the question is, why do we need grids? Here the thing is, why we need for a grids here. So large scale problems cannot be solved by a single computer. The problem is a very large that can be solved in an individual machine. For example, days of one project has to be completed. Taking one personal computer, one project has to be given to this personal computer. It may take as a, for example, it may take as a couple of days. But it has to be given with a grid computing. It has a n number of resources. The goal is one project has to be completed. The goal is a project has to be completed. Large scale of problem is considered as a project. Now it is a single computer. If it is given as a single computer, that may be take as a couple of days. Now if it is given with a grid computing, that has to be a n number of resources are existed and the data is also existed. So that may be take with a hours of time that the project has to be completed. So that is the difference with grid and the project will run at a single computer. So globally distributed data and resources. The thing is, globally, it has to be globally distributed data as well as the resources. Anywhere you can share with the data as well as the resources also. So this is the main thing we have to go for a grid computing. Resources as well as the data distributed among the all over world. Now, see here background related technologies what we use for in a grid computing. Like related technologies are cluster computing. What do you mean by cluster computing? A group of system has to be combined. We can work here. That is cluster. Next one is peer-to-peer computing. Another one is internet computing. Now see one by one now. Cluster computing. The idea is put some personal computer together and get them to communicate. That is called as a cluster. Cluster computing. Put some pieces together and get them to communicate. And it has to be cheaper to build in a mainframe computer. So compared to mainframe computer, the cluster is a better performance. And different size of clusters also existed. So some cluster may be 100 systems, another cluster may be 1,000, another may be 50,000. Like different sizes of a clusters are existed. Now scalability. We can grow cluster by adding more pieces. If you have 100 computers, we can add more 100 to that cluster. It is a scalable. Scalable means we can add a n number of computers to that clusters. Is it possible in a cluster computer? Now see in diagrammatically. This is input data as to given with a one system root node. The root node has to be shared with a slave. Another computer with have a slaves, a root node and a slave node. So the root node has to be shared. Data has to be shared to a different slave nodes. A number of slave nodes. These slave nodes has to be processed and again reback to a results to master. The master computer has to be produced with a results. So this is environment we work with a clusters. Group of. Here thing is group of computer So one root node has to be control this, that is a master node, a root node, that has to be say data to a different slave nodes. Slave nodes has to be solve that problem, again resend back to a root node, and it has to be given produce results. So this is comes under cluster architecture, cluster computing. Now second type is P2P computing. So now P2P cannot to other computers, connect to other computers. So here now connect to other computer, P2P, connect to other computers, can access files from any computer on the network without permission of a server, central server, like allowing data sharing without going through a central server. Without permission of a central server, the data can be sharing from anywhere to anywhere. So that is concept is called decentralized approach. This is very helpful for a grid computing. This is very useful for grid computing. So whatever the concept you take from P2P computing, P2P is nothing but a computer that don't be interactive with a server system. It has to be sharing the resources or data. So this is the decentralized. So that will be mostly help for a grid computing. Now this is a architecture for P2P architecture. Now one system, this is the one pieces, other it has to be interacted with other pieces, like this one has to be interacted with this one, and now for systems like this, P2P, the communication has to be the data has to be shared without permission of a server. It has to be sharing the data. Once it has to be connected through a proper authorized access, they can sharing data to one computer to other. Some grid applications we have observed here now. What are the grid applications? Now grid applications are distributed. Distributed supercomputer comes under grid. So distributed, the work has to be distributed with the different systems. So distributed supercomputing is the one of the application for a grid. High throughput computing is also one of the application of grid. High throughput is means a number of jobs completed for a particular amount of time. So high throughput. So particular we have to consider with the time, that amount of time, a number of jobs has to be completed. So that computers high throughput computing is also comes under grid applications. On demand, like we want to first we have a 10 process, 10 tasks. So I want to go for a task 2 on demand. I want to execute it for a task 2 has to be executed first among them. So first on demand computing. First it should be executed with a second task. On demand computing is also comes under with the grid computing, the priority based, and data intensive computing. So particular data we want to require, that amount of data has to be such data intensive. A particular data we want to require. For example, we want to know about India or some technologies. Then we want to require that information. So data intensive computing, that is also one of the application for grid. And collaborative, it has to be supporting with the different systems. Collaborative computing, that is also comes under grid applications. So these are all concerned with the different grid applications. Now grid users. Who is the grid users here? Many level of users here. Grid developers, tool developers inside grid, application developers, end users, and system administrators. So these are all the many levels of users in a grid. Application, grid developer, tool developer, application developer, end users, and system administrators. These are all the grid users. Now, some grid challenges are data movement. So the challenges are large amount of data from moving from one place to other places. So this is one of the challenges. Movement, we want to transferring data from Hyderabad to Bangalore to Chennai, or Chennai to Hyderabad. We want to transfer in data movement. So that is the major challenges. So a particular amount of data has to be transferred now. Still, we want to fast time within a fraction of seconds. We want to transfer with a large amount of data. So that is the one of the challenge, grid challenge. And the data replications. Replication means we have to providing the duplication. So we want to provide another copy with a different locations. So that is the another challenge. Data replications. We want to place one original copy of data, keep it at another place. Like it has to be more useful for a banking applications. Another thing is resource management. The resources like used for printers, not only printers, we concern with the different hardware resources or softwares. You have to all those things. Then resource management as particularly we want to say it here. Resource management. So resource management is also one of the important thing. And job submissions. So what jobs presently running? After completion of that jobs, what is the next to be executed here? So this is also a major challenges in a grid computing. Data movement, data replications, resource management, and job submissions. So computational grid, the posters, initially we have discussed that what is the poster definition. According to the poster definition, the hardware and the software infrastructure that provides dependable, consistent, and pervasive, inexpensive access to high performance, high-end computational capabilities. So this is the computational grid, which has to be proposed the definition by Foster. Now, what is the performance criteria here? Now, security performance criteria. See at a grid now. Security, we have to provide the data as well as the resources. We have to provide the security. This is the important thing. And the reliability. The jobs has to be reliable to execute in a particular missions. Reliability, the second concern. And the third one is the computing power. For this one, we have to see for hardware and software resources, the computing power. What is the time to complete it for n number of jobs? Latency, what is the delay to take for that? And we have to consider the performance criteria. Delay is also considered. Why it has to be taken for delay that? And the throughput. So how many number of jobs are completed at a particular amount of time? And scalability. Is it possible to improve the more system, adding with the existing systems? Scalability is existed or not? Considered with the performance criteria. Other thing is, what are the services that has to be provided? So these are all the points we discussed under the performance criteria. Grid characteristics. What are the characteristics that have the grid? So large scale. It is a large scale, and heterogeneity. So means same thing. Hetero means it is a different thing. Homo means same thing. Heterogeneity means it is have a different things. Different things has to be considered, and it has to be a multiple administration domain. It has to provide with a multiple administration domain. We can add multiple administration domain. This is provided with a multiple administration domain. Autonomy. It is a single isolation, and it has to be provided with a coordination also. Autonomy as well as the coordinations. This is the one of the major criteria, major characteristics. And dynamicity. Dynamically, the program has to be executed with dynamically. It's want to require more power of resources. Dynamically, it has to be distributed. The task has to be completed with that. And the flexibility, it has to be more flexible. And extensibility, it has to be possible to extend the different systems. And security, previously we discussed about that. Security is the more concern with the data as well as the resources. So these are all the major grid characteristics. Large scale. So here large scale means a number of things has to be submitted. So now I take the references from high performance cluster computing, architecture and systems, volume 1 by Rajkumar. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.